So this is what you're looking at right here, which is like our blueprint. And I'm going to go ahead and apologize. Any sound in the background is my two dogs. They're running around. This blueprint right here is telling me how many questions are going to be on your final exam, and what type of question. Now I can't post this per se, like can't have this up there forever. And it will change from year to year. So if you go back to this for a year from now, it'll be a little different. But there will be 24 questions on your final exam. They will be multiple choice. And then there's going to be a couple that are like multi-select, or like put them in order type deal. It'll be like a drop down. Okay. So these are all the different AKS. All of these kind of come from this, obviously from this semester. Most of these are about different types of functions. So y'all dealt with radical functions, y'all dealt with rational functions, y'all dealt with exponential. I don't know why I can't write it over here. Exponential, you dealt with logs. So those are the different types of functions that you're going to see. Now, this algebra domain is going to be like solving, okay? And then this 62 is going to be like rational functions and rewriting exponents. And again, I'll give you some examples of that in just a second. Okay, so going to your actual final exam review. Let me go ahead and clear this. So if you go to the page, and hopefully you've already looked at this and hopefully you've been working on it. But if you haven't, down here at the very, I think I put it at the bottom. Yeah. Okay, so down here at the bottom, you can access the spring final exam review guide. Okay. And what I did was I included all of these YouTube videos that have all these different questions on there. So if you want to just watch that, that's fine. I've also included these review guides and some videos. Again, this covers all of the materials that you had this semester. Okay, so coming in here, I'm going to kind of just hit a couple of different things and take questions. So again, if you're online, you can go ahead and drop those question numbers in the chat box that you want me to go over. So I'm going to hit the important ones that I think you need to make sure that you pay attention to. We talked about inverses with y'all, right? Let me check, make sure I'm not crazy. There we go. Okay. Okay, so inverse functions is going to be on there. It's AKS 38, which is right here. So that's part of that 13 questions. Okay, so you're definitely going to see that. So I'm going to go over how to do these inverse functions. Now you will deal with logs in inverse functions, but you could also deal with just regular equations, which I'll show you a version of that in just a second. So if I'm going to do the inverse, I'm going to switch my X and Y. And then I'm going to solve for Y. Okay, so those are like my two steps that I'm going to do here. So I'm going to switch my X and Y. And then I'm going to try to get Y by itself. So I'm going to subtract 6 from both sides. And so that's going to give me X minus 6 equals log of Y plus 8. Once I get here, I'm going to use the little circle of life thing that we talked about, where you start at your base. Well, since there's no number here, we assume it's 10. We go to the outside and then finish over here. So that's going to be written as 10 raised to the X minus 6 equals Y plus 8. Now, again, our goal is to get Y by itself. So I'm going to subtract 8 from both sides. And so that's going to give me 10 raised to the x minus 6 minus 8 equals y. Okay. Are there any questions on 47? Anything that I need to clarify? And again, you can put it in the chat box or you can unmute, but again, I don't know what's up with my stuff on my end. So if I can't hear you, just drop it in the chat box. Okay. Assuming. Okay, so somebody asked, why do we have log of 10 again? Remember, our number system works out of 10, base 10. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go 11, 12, 13, 14, 15, 17, 18, 19, 20. So it's in base 10. Okay. So remember, mathematicians are sometimes lazy. And so what we like to do is we like to leave things off. So like, for instance, log, if it's ever written like this, there's a baby 10 right there. So if you don't see a number, you assume it's 10 because we work out of that base 10. So I'm going to go through number 48 really quick, just to make sure that we're good. And again, if you want me to go over any specific numbers, just put them in the chat box and I can do that. Okay, so again, I'm going to switch my X and Y. And so I'm going to try to get Y by itself. So I'm going to subtract 10 from both sides. So that's going to give me X minus 10 equals log of base 6 of 4Y. Now we want to do the circle of life. In this instance, we have a 6 right there. So we're going to start at 6, go to the outside and finish over there. So that's going to give us 6 to the X minus 10 equals 4Y. Now we still want Y by itself, but it's multiplied by that 4. So we're going to divide both sides by 4. And so that's going to give me 6x to the x to the x minus 10 divided by 4 equals Y. Now remember, you're not going to divide 6 and 4 because that's a base, okay? Another way you might see this, just as like a side note, is you might see this as 1/4 times 6 raised to the x minus 10. That's a possibility, but same thing. All right, so any questions on that one? Okay, so I'm going to go ahead and hit clear. I want to talk about kind of inverse functions that aren't necessarily logs or exponentials. Okay. All right, so an example of that would be something like, let's say we had y equals x squared plus 2. Okay, so the first thing we would do if we wanted to find the inverse, we would switch our x and y. So this would be x equals y squared plus 2. Now, if we wanted y by itself, we would subtract 2. And that would give us x minus 2 equals y squared. If I wanted y by itself, I would take the square root of both sides. So that would give me positive and negative, technically, x minus 2 equals y. Okay. Now, I don't think that they're actually going to ask you whether or not it's a function, because I don't think y'all have to know that. My Algebra 2 kids do have to know it, but that being said, I'm just going to go over what that means. So if you go into Desmos, so let me move all of these tabs. So if we go to Desmos, which you will have access to Desmos on your final exam, as well as a TI-84 calculator. But let's take, okay, or not. There we go. Let's take, what we got for this one. So we're going to take log of base 6 of 4x plus 10, and we're going to plug this into Desmos. Okay, so we'll go functions, we'll go log of base 6 of 4x, and I think it was plus 10. Okay, and if I graph that, and I also graphed my inverse function, so come back in here, plus 10. Okay, so the inverse of that was 6 raised to the x minus 10. And we divided that by 4, right? Okay, so looking at our graph, it crosses over this line y equals x. Okay, so it's a reflection over the line y equals x. So notice how over that green line, it's the same on both sides. So that automatically tells you that they're inverse functions of each other. So if you don't want to have to do all the extra math, you can just graph the two equations, and then you can see that they're inverses. Somebody asked, next year we're going to be in algebra 2. No. Okay, so next year y'all would be accelerated pre-cal, because that hits the next stage. So y'all would be accelerated pre-cal. It should say that on your schedule for next year already. If it doesn't, then we need to make sure that that's taken care of. Yeah, y'all are the smart ones. All right, so with those inverse functions, I would definitely remember this y equals x. If you have compositions of functions, which again, I'm just kind of throwing this out there because I just want to make sure that y'all don't see anything crazy. If y'all saw something like this, you would take the function f and then plug g in for it. Okay, now this would be a little messy, but I'm going to show it to you anyways. So like, let's say that we took this equation right here, and we had, this is f and this is g. So if we took f and we plugged g in for it, so log of base 6 of 6 raised to the x minus 10 plus 10, and that's going to be divided by 4. And we have to multiply 4 in here, sorry, 4 times that. Okay, so if we had something like this, these 4s would cancel, these 6s and log of base 6 would cancel. So I would get x minus 10 plus 10. Well, those cancel, so I would get just x. So this f of g of x proves that they're inverses of each other because you get x down at the bottom. So if you take one and plug it into the other one, you should get x at the end. So that's another way you can tell if they're inverses of each other. Again, I don't think you're going to have a whole lot of that on your test, but just in case you've seen it. Okay. All right, anybody have any particular questions that they want me to go over? I know y'all are probably just like popping in just to check in and see. Okay, just looking back at this. Oh, somebody said 54 and 9 on the first page. Okay, so 54, yeah. Okay, so 8 upright dominoes of increasing heights are lined up to be knocked down. The dominoes are numbered 0 to 7. The smallest domino is number 0, which is 4 centimeters tall, and will be toppled by a person to start the chain reaction. Each subsequent domino is 15% taller than the one before. What's the height of domino? 7. So this is an exponential function. And the way you're going to recognize that is if it's talking about some type of percent and some initial value, it's going to deal with an exponential. So we've got 4 as our initial, and our rate is going to be 1 plus 0.15. Okay, and the way you have to think about this is we're trying to figure out what the 7th domino's height is going to be based off of the first one. So that's why we're taking the first one, we're adding 15% to it, and we're getting the next one. And we're going to do that 7 times because we're trying to figure out number 7. So we're going to take this and we're going to plug it into our calculator. So 4 times 1 plus 0.15, and we're going to raise that to the 7th power. So the 7th domino is going to be 10.64 centimeters high. Come back over here. 10.64 centimeters. Okay. Again, if you ever see something like percent, that's going to be an exponential, because that's the only thing that you really kind of seen with like compound interest and that kind of stuff. Okay. So we said 9 on the first page. Okay. So going back up here. Okay, so on number 9, when you sketch the graph of these, plug it in Desmos, because again, you're going to have access to it. So we've got square root of x minus 1. Okay, and I know on your paper it says like find the domain and range. So we're going to do that. Okay, so when we do domain, our farthest left x value, that's like right here. What value is that? Well, that's, if my mouse would work, that's 1, 0. Okay, so my farthest left x value is 1. And what's my farthest right x value? Well, it keeps going off the page, right? So that's going to be infinity. Okay, my range is going to be my lowest y value, which again is 0. And what's my highest y value? Well, it keeps going up off the page. So infinity. Okay, domain is what's my farthest left to my farthest right, and range is what's my lowest to my highest. Okay. Okay. Anything else that y'all want me to go through? Okay, so other things, 57, okay. Sketch the solution. Okay, so again, I would definitely use my Desmos, because I would not want to do this by hand, and you're not going to have to do it by hand. So you're going to take these and you're going to put them into Desmos here. Okay, so you're going to go y is greater than or equal to 1/2 x minus 1. On the next one, you got y is less than or equal to negative 1/2 x minus 3. Let me go ahead and zoom out because I know that's messy. Okay, so what you'll draw on your paper is you'll draw these lines. So you'll do like a sketch of those 2 lines, and they'll be solid because there's a line underneath. Okay, and the only shaded region that you want to include is this guy, because that's where they cross over. Okay, you might be asked something like, what is a value that is a solution to the system? Okay, so like, for instance, negative 50.0, I'm sorry, negative 50, 0 would be a solution. Okay, so they might ask you something like that. You just got to make sure that it works for both inequalities. Okay, so if I plug in negative 50, 0 into both of those inequalities, it works. You could pick any number or any point over on this side. $17. Yeah, those are fun. Okay, so this is using those exponent rules. So remember, if I have an exponent raised to an exponent, that means I'm going to multiply them together. If I have a negative exponent, I'm going to write these down. Negative, you're going to flip it. If I have an exponent raised to an exponent, you're going to multiply them. And then if I have I'm not going to run into that scenario, so it'll be fun. Okay, so right here, this is negative 1.5. So this is going to be 1 over 49 r squared raised to the 1.5. So all I've done so far is I've just flipped the fraction. Okay. Now this 1.5, I suggest turning it into a fraction. Some people like working with decimals instead. That's fine. But I'm going to turn this into a fraction. So I'm going to raise both of these things by 3 halves. So 49 raised to the 3 halves, r squared raised to the 3 halves. And again, we just talked about it. Exponent raised to an exponent. That means I'm going to multiply those exponents. So 2 times 3 halves is going to give me 3. And 49 raised to the 3 halves. I would go into my calculator and just plug this in. So I would take 49 and raise it to the 3 halves power, and that gives me 343. So it's going to give me 343. And remember, this should be 1 over all of that. So that would be my final answer. I know that one's a little tricky. The way you're probably going to see this one is something like this. Okay, so what this is asking you to do here, this is the same concept. You're just dealing with numbers over here, but you're dealing with variables over here. So what this is asking you to do is use your exponent rules and simplify. So I'm actually going to work this one out, and you can just do it either on the side or on a separate sheet of paper. So if we have a negative, we're going to put it on the opposite side of the division line. So this will be a times a squared, b squared, c over anything raised to the 0 power is going to be 1. So that's just going to cancel. And then c to the 2nd power. Now, if they're on the same side of the division line, you can multiply them and add those exponents. So what's 1 plus 2? That's going to give me 3. And then what's 1 minus 2? That's going to give me -1. So that -1 is going to go down on the bottom. So if we have the same base, so if we have something like this, so like a to the 1st times a to the 2nd, that gave us a to the 3rd. So we added our exponents. If we had something like a to the 6th divided by a to the 5th, we're going to subtract our exponents. Okay, those are the different properties that you may run into. Okay, again, this final exam, I don't get to see it prior to y'all taking it, so I'm just taking my best guess at what it would look like. Okay. I'm gonna undo. See, I'll have that second. Other things kind of just want to talk about. There will be probably like 2 or 3 questions where you've got to read. Make sure that you pay attention to like domain and range in context. Y'all did not so great on one of the problems. It was like the first test y'all took with me where it was like a tsunami or something like that. And the domain went into the negatives, but you can't have that happen in real life scenarios. So you got to make sure that when you're reading a scenario, think about real world context if it is a word problem. Now, if it's a function, obviously negatives can happen. If it's real world, you can't have negative time. You can't have negative shirts. You can't have negative whatever, okay? So just keep that in mind as y'all are going through those questions. What was the other thing I wanted to tell y'all? I'm gonna write down these AKS really quick, and then I'm gonna talk you through what specifically these are. I think these align with my Algebra 2 kids, so should be okay. 40, 42, and 62. Okay. So 10 is going to be identifying the zeros. Maybe I should actually make a list on this one. Yep, I'm gonna do that. Okay, so if you joined us a little late, there's going to be 24 questions that are multiple choice. Okay, and there's going to be some that are like multi-select, but again, that's the same thing as multiple choice, in my opinion. AKS 10 is going to be solve for the zeros of a rational function. Remember, rational functions are something that looks like this. I may not have one of these on your final exam review guide, but y'all were pretty good at this. I didn't have any problems with y'all. And then it would be like, okay, solve for the zeros. Okay. 16. 16 is going to be constraints or inequalities. Okay, so back over here. 16 is constraints or inequalities. So this would be like, hey, your mom told you you only have $20 to spend at the supermarket, and you have to spend $5 on a certain thing. This was a lot like your performance final, where you would have like iPhones and Androids. I think that was the thing. iPhones and Androids, and you were trying to like produce them. And iPhones are $200 and Androids are $160. And let's say that you have to have greater than 0 iPhones and then greater than 0 Androids. It'd be something like that. Okay, let me look at the other one, 18. Okay, 18 is solving simple and rational and radical equations in one variable. So let me type that up. Okay, so examples of that one is going to be something like what's on this paper. So something like this, like number 1, and then solve for x. Okay. One. So many 21s in this document. Okay, this one is going to be 21 is going to be about rational functions and adding and subtracting and dividing. And again, y'all were pretty good. I was actually pleasantly surprised at how good y'all were at that. So something like that would be, it'd be like, okay, solve for x. That's what it would be. So remember, you would have to have the same denominator. So you would multiply this guy by x minus 2, multiply this guy by x minus 4, and then kind of solve from there. Okay. And the next one would be, okay. Explain why the x coordinates of the points where the graphs intersect are the solutions of the equations, or find the solutions approximately. So you would be given something like 2 equations, and where they cross over, where they intersect, that would be the solution. That's all they're asking for. There would probably be like one question on that, and it would be a word problem because they'd try to trip you up with it. But it shouldn't be too difficult. Just graph whatever the equations are, graph both of them, and wherever they intersect, that's going to be a solution. Again, y'all were pretty good at that one. This is where I think you might struggle. 23. Okay, 23 is going to be key features. Okay, and this could be key features of any type of function that we've talked about so far. So this would be something like domain, range, in behavior, increasing, decreasing intervals, anything that like that. Okay. Normally that's going to be some type of function, and then they'll just say, hey, what's the domain? But I think you'll be okay on that one as long as you're good. Like if you did the domain and range on these, you should be okay. Okay, 26. And as I'm going through these, if you have any questions, you again can just drop them in the chat box, and I can go through them in just a second. Okay, graph functions expressed symbolically and show key features. So this is going to be, like identify the graph for the equation that they give you. So like pick which one matches with the graph. So basically what you would do, plug it into Desmos and then pick whichever one coincides with that. Just be careful because they like to do some sneaky stuff. You will be on a laptop when you take this. So if you need to make it bigger, like if you can't see the graph, there's like a magnifying glass up at the top, or Control+ sign will make the screen a little bit bigger. I know I struggled with seeing some of them. 30. Graph exponential and logarithmic functions and showing intercepts and in behavior. Okay. I can spell exponential and log functions. So this is going to be like what's on your final exam review. So this, and they would have, 4 different equations or 4 different graphs that you can pick from, and you pick the right one. Again, you're going to have access to Desmos, so you should be okay. Okay. I make it sound like y'all aren't going to do well on this exam. That's not the case. Y'all are going to do well. It's going to be okay. 38 is find the inverse. Okay, so that's that switching that X and Y and solving for your Y. Now it could be a log function, or it could be a rational function. I could see them doing that. And again, we can do an example of it if we need to. But again, you switch your X and Y, solve. And the easiest way to check for that is if you plot both the original and the potential inverse, they should reflect across that line Y equals X. If they don't look the same on both sides, then they're not inverses of each other. Okay. 40. Verify by composition. Okay, so you will have a composition one, and it's going to ask something about like Y equals X. That is something you need to know. Okay. So again, if you weren't here earlier, 40, verify by composition. No, final is not curved. Somebody just asked if the final will be curved. Nope, it's not curved. You want to do well on this one. So for composition, okay, what you're going to do is, let's say I had, okay, let's say that I had an f of x, and let's make it super easy. It's x plus 2. And let's say, I gotta find its inverse really quick. So let me find my inverse. Okay, so let's say g of x equals x minus 2. Okay, to verify the composition, you're gonna do f of g of x. Okay, so that's gonna take f. And instead of putting just x, we're going to write out what g is. So this entire thing. Okay, so instead of writing x, we're going to write sorry, I was going to do it in a different color. There we go. X minus 2. So notice how that's the same thing as what g is. And then I'm going to simplify. Well, negative 2 plus 2 is going to cancel, and that'll give me x. Okay, if I get x at the end, then yes, they are inverses of each other. Okay, so if you plug one into the other and you get x at the end, once you simplify, they're inverses of each other. Another way you could have done that, again, go into Desmos and plot both the original and the inverse. And on this one, it's a little bit harder to see. But if you plot the line y equals x, it's a reflection over that red line. Okay, so it's like the same on both sides. Okay, 42. All right, 42 is understanding the inverse relationship between exponent and logs and using it to solve the problems. Okay, so 42 specifically is inverses of exponential and log. So what I need you to understand, I'm gonna write that down here, 42, inverse, log, and exponential. Okay, so what you need to get from that is, if I have log of base 4 of 16 equals x, I can rewrite this in an exponential form that I can solve for x. So I would start at my base, go to my outside, finish at my exponent, or finish over here. So this will be 4 raised to the x equals 16. So what is x going to equal? 2. Okay. Now, if you're given this exponential and you want to go back to log, you start at your base, you go to your outside, you finish at your exponent. So log of base 4 of 16 equals x. So notice how I followed that circle in that pattern. That's how I wrote out my other things. Okay, so understanding you can go from logs to exponential and vice versa. Okay. All right, and the last section is 62. Where you at? Sure. Rewrite involving radicals and rational exponents. Okay. So this is going to be something like rewrite exponent to radical. Okay, so this would be something like understanding that if I had x to the 3/2, that's the same thing as saying the square root of x to the 3rd power. Okay, and being able to go back and forth. Okay, if you want some practice on this, I would maybe do questions, I think it was like 40, no, just kidding. There you go, 23 through 26. That's basically this AKS. Okay, so just to kind of give you an example, if I had this one right here, 23, I want to rewrite this in exponential form. Okay, so I know that the square root of something is the same thing as taking something and raising it to the 1/2 power. Okay, so I could write it like this, or I could write it out as 6 to the 1/2 into the 1/2. Because remember, our exponent rule states that if we have an exponent, we're going to distribute it to everything that's inside that parentheses. Okay. I'm going to do 26 just to kind of give you another example. So if I have this right here, I have a cubic root. So that's the same thing as taking something and raising it to the 1/3 power. But remember, we've got to square it out here. So we've got a power raised to a power. So that means that I'm going to take that exponent and multiply it by this exponent, which will give me 2/3. Again, you could leave it like this, or you could leave it like 4 to the 2/3, r to the 2/3. Now there's going to be 2 questions like that. So 62 is definitely something that you want to know. All right, so coming back over here. Okay, so looking at our different AKS in these different concepts, remember there are 24 multiple choice questions, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we know that 62 has at least 2 questions on it. Okay, so you're going to have one of each of these, at least maybe 2 of them. Okay, it just depends. Are there any of these concepts that you want me to go over kind of more in depth? And again, if I can't hear you, just drop it in the chat box. Or if you just don't want to talk, that's okay too. Like any of these concepts that you're like kind of afraid of. Don't say the whole thing. Verify by composition. Yeah. Any other ones? Okay, so I'm going to give you an example of this one. The question's going to say, all right, f of x is x plus 3, and g of x is x squared plus 2x. and they say, like, tell whether these are inverses. Okay, then what you're gonna do is you're gonna take f of g of x, right? Okay, so you're gonna take what f is, and instead of writing this x, you're gonna take what all of g of x is. Okay, so what I like to do is I like to write what f is out, and then erase that x and rewrite it as g of x. Okay, now my question to you, can we simplify this at all? No, that's it. This is it. So is this equal to x? No. So are these inverses? No, they aren't. Okay, so that would be an example of them not being inverse functions, which can happen. Okay, I'm going to give you another example, and then I'm going to hit up some key features in just a second. So let's do f of x equals x squared, and g of x equals the square root of x. Do you mean, Taylor, do you mean f of x equals x minus 2 and g of x equals x minus 1? Is that what you're saying? Okay, so like if I had that, and we're going to try to see if those are inverses of each other. Okay, so if I had these two equations right here, and I said f of g of x, so I'm going to take f, and instead of writing this x, I'm going to write what g is, which is x minus 1. So can I simplify this? Well, what's negative 1 minus 2? Negative 3. So this will be x minus 3. Is that equal to just x? No, so they aren't inverses of each other. Does that make sense? Okay. All right, so somebody asked me for key features. So give me the type of function you want to deal with. Like exponential, linear, quadratic, rational, radical. Give me which type of function so I can come up with one. Radical. Okay, I can do that. Let's actually do an example from one of our final exam review questions. Let's do, I know we had radicals on here. I think it was at the beginning. Whoopsie. Okay, let's do like number 10. Okay, and let's do all the key features that you might see. Okay, so I've got the cubic root of x plus 4 plus 1. Okay, so what I'm going to do first is I'm going to put this into Desmos. Okay. Now, how I do cubic root functions is you go into functions and you scroll down to where it's got this in roots button. Okay, and I'm going to type a little 3 out here, and then I'm going to say x plus 4, and that plus 1 is outside the radical. So we're going to say plus 1 outside. Okay. All right, so now what we're going to do is we're going to state the domain. How far left does our x values go? Well, they go on forever, right? So that's going to be negative infinity. How far right do they go? Positive infinity. Does that make sense so far? And just drop questions in that chat box and I can help you out. For range, how far down does it go? Negative infinity. How far up does it go? Positive infinity. Okay. So is this function increasing or is it decreasing? Well, it's going up the entire time. Okay, you want to think about reading from left to right. That's how you normally read, right? So if you started over here, then you're going up the entire time. So it's increasing the entire time from negative infinity. So from the left to the right, it's increasing the entire time. Okay, it's kind of like Goliath. Somebody asked, so range is the highest and lowest, and domain is the lowest. I'm pretty sure you were trying to say X value. Yeah. Okay, so range is going to be, let me do this. Range is from bottom to top, and domain is from left to right. Okay. And yeah, it's the lowest to the highest. And from farthest left to farthest right. Yeah. What's the other thing you might run into? In behavior. And that's another thing you might see. So in behavior would be like as X is approaching negative infinity. So in this instance, we're standing at 0, 0. We're right here. My lovely stick people. I'm so sorry. As we look to the left, what's happening to our Y values? Well, they're going down, right? And then as we look to the right, so as we look this way, what's happening to our Y values? They're going up. Okay, so with key features, it's kind of like, it's all about like perspective. Like if you're standing over here as this blue guy, okay, you see that the function is increasing. If you're standing in the middle though, you see it's kind of like going down on the left side and going up on the right hand side. Okay, so it's all about perception. Okay, let's do another one. So this time I'm going to just do like a regular square root, nothing crazy. Okay, so if I had something like, let's do 11. So 2 square root of X plus 2. 2 square root of X, and that's outside plus 2. Okay. So in this instance, we only have like the graph's kind of like going off to one side and there's nothing going on the left-hand side. So you want to see where your start is on the left-hand side. So this only goes to 0, right? Like it doesn't go farther to the left. So my domain is going to go from 0 to how far right does it go? Well, it keeps going. So that's going to be infinity. For my range, what's my lowest Y value? Okay, well, looking at this point right here, my lowest Y is 2. There's nothing that's below it, right? So this is going to be 2 to positive infinity. Okay. For this one, is it increasing or is it decreasing? Well, starting over here, and I keep going along my little curve, it's increasing, right? Well, where is it increasing from? Well, from our domain, it's happening the entire time. So it's going to be from 0 to positive infinity. Are there any X-intercepts in here? No, because it doesn't cross the x-axis. Are there any y-intercepts? Well, it crosses the y-axis right here. Well, at what value? At 0, 2. Okay. Again, let's talk about in behavior because I think you're going to see that probably. So in behavior, and again, it's all about perspective. So we're standing at 0, 0. And so in this case, we're going to say as x is approaching 0 from the right-hand side, and you probably won't see that notation, but just in case, that's how you actually read it. What is your y doing? Well, it's getting closer and closer to this value 2. So as we're looking to the left, it's going to be going closer to 2. As we get farther right, what's happening to our y values? They're just keep on going up. Okay. Anything else y'all want me to go over? Looking back at this little chart or this little table. I don't want to erase that yet. We're good on rational functions. I think y'all will be okay on, again, on most of this, you can probably plug it into your calculator and kind of figure it out from there. If they give you something like, what's the solution to this radical or rational, like plug your options in and check and see if it works on both sides. Like, don't make it tricky. Don't try to solve it out. Like if you're not really prepared for this test and you haven't been paying attention all semester, plug it in, right? Don't do nothing crazy, plug it in, okay? If it works on both sides, it's probably a solution, okay? Y'all can identify a graph. I think finding the inverse is probably something we might struggle with, but again, take those two, take the original, take one of the choices, graph them both, and see where they reflect over that line y equals x. Okay, so it should look like, I always think of like a butterfly. It should be symmetrical on both sides. Okay. Anything else either from your review guide or anything that's like worrisome on here? I am. Yeah, I'm gonna drop this on y'all's e-class page, probably under just the announcements and probably on the remind just in case. Yeah. Somebody, oh, I'm sorry. Somebody asked, are you gonna post this recording on your YouTube channel? Yes. Hashtag subscribe, maybe? No, just kidding. Don't do that. Okay. If you don't have any questions, feel free to jump off. I'm not going to hold you. If you want to stick around and you want to ask some questions, I'm just going to stop hitting record on this. So again, if you got some questions, you can stick around. Otherwise, y'all are free to go. If you are in first period, you will be taking your exam tomorrow. No. Yes. No. Tomorrow is sixth period. Just kidding. Tomorrow's sixth period, and then first period is on Friday. So I will be in there with y'all during 6th. So if you have any like last minute questions, Thursday. Okay, so really quick, The schedule for this week. Let me pull it up. Okay, so tomorrow you should take 6th period, and then Thursday you'll take 7th, and then Friday you'll take 1st. So if you're in the accelerated geometry class, you're gonna take it 6th and 1st, so whichever one you have. Okay. During 7th period, you're gonna be doing like kind of like a little delta math test. It's not gonna be something crazy. It won't be that long. Okay. All right. Again, I'm gonna hit stop recording, but if you want to stick around and ask questions, that's fine too. So.